Okay, let's go ahead and talk about the rest of the test. Page 39, or question 39 on the calculator section. We'll try to finish this up here. They want us on number 39 to find the derivative and see where it's equal to slope of the tangent line of negative 1.024. So we have a couple of choices here. We could go ahead and take the derivative. Another choice, and I'll show you that, is to basically put this graph in and go through the answer choices, finding the derivative at each of the answers that they found. For instance, if I go to second calculate and find number 6, I'm looking for the answer to be negative 1.024. So I could try, for instance, answer choice B, which is 1.277. And I see there that the derivative is 2.35, so that's not the answer. So, that's certainly one way to do it. Another way to do it is to find the derivative, put it in the calculator, then set it equal to 1.024. So let's just do that real quick. So the derivative would be the quotient rule. So the derivative of the top is 9x squared times the bottom function minus e to the x is e to the x. That's the derivative, right? And this would be 3x cubed. Now you have to square the bottom one. So e to the x squared plus just 2x, e to the 2x. Anyway, so you just put this whole thing in your calculator, the y1, I guess, and in y2, put the negative 1.024, and then just look to see where they intersect. That'll give you your answer as well. So let you finish that one up. Number 40, they want to know, the graph is shown above. If this is g of x, this is the graph of f, right? And g of x is defined by what? It's defined by this a to x of f of t, dt. So remember the second fundamental theorem. If I take the derivative of both sides, this basically cancels out integration, differentiation. So this is f of x first t. Right? So see that cancellation right there. Now this is equal to the derivative of g. So if they want to know when does g have a relative minimum, g of x have a relative minimum. So relative minimum, of course, is q. There would be a relative max. There's a relative min, I guess. So the slope of the derivative here is positive. Tangent lines are negative over here. It's flat right there. That's changing from positive to negative. Gives me the max. And here, different color, we have negative and positive on the other side of the turn here. So when it goes from negative to positive, we have a relative minimum. So when does this occur? When does it go from negative? Well, it's negative here, and it turns positive here, so it kind of looks like a pretty simple problem. All right, let's move on to 41. 41 says if the graph is given of the function, they want to know when it changes concavity. So, well, first thing we could do is take the first derivative, because concavity requires that you know the second. So the first derivative is this, derivative of sine is cosine, and now the second derivative is the first derivative. This would be 20x cubed minus 2 minus sine of x. So what are we looking for? We're looking for where this thing changes from positive to negative. So we're just going to put this in the calculator and test our points out. All right. So we have 20x cubed minus 2 minus 2 minus sine of x. And take a look at it. And maybe we shouldn't even look at the graph. Let's just go look at the table. And since the answer choices are clearly decimal, all we have to do is change the ask the independent variable, and we can go just type in the answer to see where we get a 0 or close to 0. We have 0.324. And negative 1.638. Luckily, these answers are in order from least to greatest, so check out 0.499. It's 0.00648, so that's pretty close to 0. Let's see what's happening just a little bit to the left of it. 5.5. And it's getting bigger, and it's becoming more positive, I guess you could. We can look at a little bit more. 0.506, the answer choice C, and it's getting bigger and bigger. So you can run through these if you'd like, but I'm pretty convinced that 0.499 is a good answer. Okay, let's move on to 42. 42 has a graph shown, and this is similar to number 40, where they give us, see if we understand the second fundamental term of calculus. Except for this is from 0 to x, and they changed it to f of x and h. Sorry. Anyway, they give us that h is the graph shown above. So this graph is also the derivative of f, right? They want to know which of the following could be the graph. So it looks like this derivative of f is defined everywhere. You can take the second derivative as well. And so if you take the second derivative of f, of course we can do it algebraic, numerically, but we can look at the sign, right? You know that it looks like it's equal to 0 at a, right? So the second derivative is flat there. Positive slope here, right? Then it becomes negative slope over here. Negative slope until we get to some point that's not defined on our graph. I guess we could define that. We can just call that d. And then it changes concavity because it becomes positive everywhere after that. So we're looking for a graph that is concave up and concave down between 2 points A and B. They didn't draw for you on the answer choices, and then it becomes concave up. So, of course, this A would be a point of inflection. So maybe that's a hint for you to go look at your answer choices. All right, 43. 43 is a table problem, and these turn out to be not too bad once you get a little practice with them. 43, they're asking you to find the area under the curve. How do they ask that? They give you this. They tell you that you're looking for the right-hand Riemann sum. And so the x values go from 0 to 6. And they want you to divide it up into How many intervals? 3 equal subintervals. So this will tell me how wide to go. So the width of these guys is 2. And since we're using the right-hand sum, we're going to pick up this one, and this one, right? Because this is the first rectangle we're going to draw. This would be the second one. And then the third one has an endpoint at 6. Because we're using the right-hand sum, so you go to the rightmost value. So the area formula is length times width. Each one of these is 2 wide, so we're just going to multiply 2 times the function value at what? 2, 4, and 6. F of 2 plus f of 4 plus function value at 6, and you just pick these right off the table. Should be good to go with that. Fairly straightforward question. Let's see, 44 has a graph and then some statements, and you have to verify which one of these is false. So part A says it's continuous but not differentiable at x equals a. Continuous but not differentiable at a. At point A. Well, it is continuous here, right? Continues on, but you can see that cusp point right there, so this one is certainly going to be classified as true. And part B, what are they asking us for? I don't think I'm going to write this whole thing out, but it says the limit as x approaches a to the left, and they give you this whole equation here, which you should recognize as the derivative, right? So they're basically saying, does the derivative exist at point A? Because over here on the other side they have the limit as x approaches a from the right over here, and it's the same equation. So just looking at the graph, you can see that it's not, derivative is not defined there, so the limit of the derivative is not defined as well. So part B is true because they have this big all-important not equal to sign. So let's take a look at C. See how C pans out. C says f of A is defined, but f of C is not. F of A has a point, and f of C does not. And you can see that f of C, there's no point on the graph. Had they have given us a dot down here, let's say, function is defined there, even though it's not continuous. Anyway, so that one's true as well. D says, can you take the derivative at point B? Well, point B looks like a nice smooth spot on the curve, so you can certainly take the derivative of that. So by the process of elimination, we've come to the conclusion, and it basically says the limit as x approaches C from the left is not equal limit at C from the left is not equal to the limit of C to the right, the positive, right? Well, the limits are there. They both approach some number, like maybe 4, from the left and the right. So that is a false statement. Had they asked about continuity, though, of course that would be a different story. All right, so let's take a look at the very last one, 45. It should be fairly straightforward. They have a piecewise function of negative x squared and square root of x, second piece. And this is when x is greater than 0 and when x is less than or equal to 0. And they ask you a question. They tell you that g of x is equal to negative 2 to x of f of t. So this function over here with f. Wise. All right, so they're saying the value of x not equal to negative 2. If g of x ever equals 0. So would g of x ever equal 0? Well, let's split this up. It's going to go up in two separate places, okay? You know it always has to start off at negative 2, right? Well, this gives us a hint right here. And 0 is where the piecewise split up. So let's split it up in two spots. Okay. Now, this interval here between negative 2 and 0 is clearly less than 0, so we would have to use negative x squared. And this point here is greater than 0, so we would have to use x to the 1/2 power or the square root of x. So let's take a look at these two integrals here and see if this helps. The integral of negative x squared would be negative x cubed over 3. And we're looking at it from negative 2 to 0. And this one over here would be 0 to 2. Oops. Go ahead and add 1 to this, right? Get x to the 3/2. Okay, and we're looking at it from 0 to 2. We're adding these two together. All right, so plug in 0 on the green one here, you get 0 over 3. 0. And then you have minus negative x cubed over 3. We're putting in a negative 2. On the black one over here, we have 2 3/2 power over 3. And over here, this would be negative 2 cubed is negative 8. We have negative 8 thirds. But this minus turns out to be plus, right? So still have negative 8 thirds plus 2 to the 3rd power, 8. This is black. We have 2 times 8 square root of 8 over 3. Let's see if this gets us anywhere. This is 4 times the square root of 2. This is 2 square root of 2, so we have 4 square root of 2 over 2 plus negative 8 thirds. Oh. So at 2, I was checking out answer C. Answer choice C does not work. I should have explained what I was doing. Here, this is answer choice C. So answer choice C didn't work, but I want to clue you in on this part right here. Actually, the integral is going to be the same, right? It's always going to be x to the third over 3 when it's less than. So all these answer choices are positive, right? So this part's always going to be from 0 to -2 when we evaluate it. And the only thing that's going to change is we're still going to have 2/3 x 3/2. All right, well, since this part always equals a -8/3, and they want to know if it's ever going to equal to 0 again, move this over and equal 8/3. So basically, black one is equal to 8/3. What you're looking for, right? So really, you can just concentrate on this half of the equation. This part right here will make it in red over here. So let's go ahead and work this one out. You know that we're going to cube this answer. So let's just focus in on answer choice D, just to make the sake of time. If we plug in 2 times the cube root of 2, which this is answer choice D right here. And when you cube the cube root, that goes away. But then you got to take what? Square root of it? Right? So 3/2 power times 2 times another 2 over 3. I made a mistake, didn't I? What else do we need to do? We did have to cube this, but we also have to cube that 2 out in front. So let's do that. We have our original 2, this one. 2 cubed is 8. That's the leading one right there. And this is still equal to what? It's equal to 2. And then we have to take 1/2 power. So basically, I hadn't taken care of the denominator yet. Over 3. All right. So 8 times 2 is 16. And we have square root 16 times 2 over 3. Does that equal 8/3? And of course it does. So that's sort of an involved one, but hopefully if you have time you could work that one out. All right. Best of luck to you. See you soon.